Cisco Express Forwarding, the biggest, baddest, fastest switching method that we have available on our Catalyst switches. It's also known as topology-based switching, a term that is interchangeable with Cisco Express Forwarding. Keep that in mind. So what makes it the fastest method? Well, what is at the control plane? All the tables, all the information that is necessary to make forwarding decisions. So why bug the control plane all the time like you would with process switching? Or why bug the control plane once for every single flow and create a route cache like you would for fast switching? Why not instead create tables ahead of time at the data plane? Tables like the forwarding information base, which is very similar to the routing table. Tables like the adjacency table, which is similar to an ARP cache. What about TCAMs? TCAM tables that have security ACLs, quality of service entries that can be quickly and efficiently looked up at the data plane instead of having to bug the control plane. That's what Cisco Express Forwarding is all about. Taking the information that is gathered ahead of time at the control plane. Information that's gathered by routing protocols as an example. Information that's gathered through access control lists, quality of service features. Putting that down at the data plane right away. Pre-populate all that information. That way there, the only time that we'd ever have to bug the control plane is if there was not an entry in the data plane. And this would be known as punting. So let's say a packet arrives and we don't have the information at the data plane. We punt the packet to the control plane to get the information that is necessary, and then we will populate the data plane appropriately based on the information gathered. But the majority of the time, the data plane will already have the information pre-populated. And since it's pre-populated, forwarding is much more efficient, or switching is much more efficient, because a packet arrives, it gets sent to the tables that are inside the data plane, and then it's forwarded out the correct interface. At no time do we have to access the control plane unless there's information missing. This is a much faster, quicker, efficient process. CEF, Cisco Express Forwarding. What we're looking at right now is centralized switching for CEF. Centralized switching, meaning that there's a centralized repository of tables and information at the data plane that are going to be utilized to make forwarding decisions. However, on higher end Catalyst switches, we could have distributed switching. What is distributed switching? Well, let me draw a Catalyst switch with different line cards in it. Different line cards, meaning different interfaces on those line cards. Well, we could take these tables at the data plane, the fib, the adjacency table, the TCAM tables that are generated, and have copies of them now at the line cards for the interfaces. And since we'll have them at the line cards on the interfaces, it makes the process even more efficient on these higher end Catalyst switches. Now, why is it more efficient? Well, imagine a packet arriving in on this line card. Instead of having to ask the central repository up here of information, we already have that information stored on the line card itself. So the packet comes in, the packet goes out. Don't have to analyze the information in the centralized repository. So this would be distributed switching. Or a packet arrives inbound on this line card, gets sent to this line card, making it that much quicker, that much more efficient. So we don't have to bug the centralized repository up here anymore. So what does that mean for traffic flow? Well, a packet arriving inbound gets checked against the distributed information, and out it goes. much quicker, much more efficient, making the forwarding of packets very, very close to line speed. Very close to line speed. So Ceph is on by default. Ceph is the way to go. But I've been talking up Ceph. I'm saying it's so awesome. It's so perfect. I do have to tell you about one of the little issues that you may run into. Let me add a few devices here. Connect them up to this router. We'll add a server down here. Connect up the server to the router. Let's add some additional lines. All right. Let's say we're running EIGRP. GRP. I don't know how to spell EIGRP. There we go. We have equal path load balancing happening here. So EIGRP has determined that there's two paths that can be utilized. However, Ceph uses, I want you to notice this, per destination load balancing. So if every single one of these devices want to go to that server, which path is going to be used? Are we going to equally load balance? And the answer is no. Per destination means every single packet is going this way. This is known as Ceph polarization. Just keep that in the back of your mind. Ceph polarization. Because of this per destination load balancing, all those packets are taking the same path, even though there's another path that can be utilized. This is going to occur in the environments where you have very few destinations or a small number of destinations, and everybody's going to those same destinations. Or if you have a heavy lean towards a certain traffic flow, then it's all going to take the same path based on the destination. You can tweak this, though. And that's why I'm telling you this. You can tweak it. So if you do end up in this Ceph polarization issue, you can tweak it. And as a result, you could, for example, take a per packet load balancing instead, whereby packets then are evenly distributed or load balanced on a packet by packet basis. You go this way, you go that way, you go this way, that way. But then Ceph is not as efficient as it would be with per destination load balancing. Just keep that in mind. But most people won't run into this problem simply because there's going to be a lot of different destinations that a lot of different devices want to reach. So in reality, based on destinations, this typically won't happen. But if it does, make sure you recognize it and know that you could tweak it if you must in order to improve the traffic flow. So Ceph is what you want to be using. It's the fastest method, hardware, forwarding, switching those packets from the ingress interface to the egress interface really, really quickly by simply looking at the tables that are down in the data plane.